Hi, I will be doing question number 63 from 1.1. The question says, a box with an open top is to be constructed from a rectangular piece of cardboard with dimensions 12 inches by 20 inches by cutting out equal squares of side X at each corner and then folding up the sides as in the figure. Express the volume V of the box as a function of X. So here we have a diagram of the figures. And we can represent the length of this rectangle, or this box, as length is equal to 20. And we can subtract 2x, because there are two x lengths that are being cut out from the length. So 20 minus 2x is equal to your length. And our width can be represented as 12 minus 2x, as shown in this diagram. And then the height of the box is simply x. So then our expression for volume is going to be length times width times height. So if we substitute the expressions that we found in the previous step, we get volume is equal to 20 minus 2x times 12 minus 2x times x. So then if we expand this equation, we end up with 240 minus 64x plus 4x squared, all times x. And if we expand it again, we end up with 4x cubed minus 64x squared plus 240x. Thus, the volume of the box can be expressed as 4x cubed minus 64x squared plus 240x. And now if we look at the domain of this function, we know that L, which is the length, has to be greater than 0, W, which is the width, also has to be greater than 0, and X has to be greater than 0, or the height, because you cannot take negative measurements, so all of these measurements have to be greater than 0. So if we take a look at the length, that means 20 minus 2x must be greater than 0. 2x is greater than 20, which means x is greater than 0 and less than 10. So that is our domain for the length. If we look at the width, 12 minus 2x is greater than 0. 2x is greater than 12, which means that x is greater than 0 and less than 6. So then our final domain is going to be x has to be in between 0 and 6. That is our domain.